Hi, 7th graders. Today we're going to do section 9.6, which deals with surface area. We have been working with 2D shapes, where all the shapes are on one flat plane. Today we're going to talk about 3D shapes, which involve multiple planes. 3D figures are shapes that have length, width, and height. So my cube here, if you notice, is a 3D shape. It's got its length, its width, and its height here. And so that is what makes it a 3D shape. Now, we're going to talk about special types of 3D shapes. And the one type we're going to talk about are polyhedrons. Polyhedrons are a closed 3D shape, like my cube here, that has flat surfaces. And my flat surfaces have to be polygons. Remember what a polygon is? It is an enclosed shape that is made up of line segments. So this is a polyhedron because it is made up of polygons. Now I'm going to show you from our book some examples that are not polyhedrons. Right here, a circular cylinder is not a polyhedron because it's got a circle for its base. So is my circular cone, and our special 3D shape, everyone wants to call it a ball, but its official name is a sphere. These are not polyhedrons because they're not made up of all straight line segments. Okay, so let's look at some special types of polyhedrons. The first one we're going to talk about are prisms, okay? Prisms are a solid figure with two congruent polygons for bases. This shape right here, my cube, is another example of a prism, okay? It's got a base, two bases that are exactly the same that are congruent, and it's connected by sides that are all polygons. In your book, you'll see a whole bunch of different examples here. They give you a cube. Here's a rectangular prism. Notice the bases are exactly the same. They're rectangles. Here I've got a triangular prism. The bottom and the top, the base, are triangles. Here we've got a hexagonal prism. The bases are hexagons. If you notice, all the edges that are connecting my bases in all of these examples are either rectangles or squares. So that is what makes it a prism. Now with a prism, we have special shapes that we talk about. I've used the term face. What exactly is a face? A face is the flat plane that makes up all of our shapes. So a face is our bases. It's the edge that connects them through. And then we have what is called edges. Edges are that straight line that connects our multiple faces. And then we have what is vertex. Our vertex is the point where we've got three edges that come together and forms a point. That is a vertex. Okay, now there's another shape, another special polyhedron we're going to talk about, and that's called a pyramid. A pyramid is not with two bases, but it has one base. So if you take a look here, I've got a triangular pyramid. If you notice, it's named by the one base that it has. Here's a rectangular prism. The base is a rectangle. Here I have a pentagonal pyramid. The base, guess what, is a pentagon. Now take a look at these shapes. All of these pyramids, what shape is the face that comes up to the vertex? They're all triangles. It doesn't matter what its base is. All of the faces, the side faces, if you want to call it that, are all triangles. And with a pyramid, all our triangular faces meet at one point, and that is called our vertex. Okay, so we have two special types of polyhedrons. We have our prisms and our pyramids. So let's take a look at our example here. Here I have a shape. What would I call that shape? The shape is a triangular prism. It has two exact same bases that are triangles. Okay, then our example says, how many faces are there? Faces are all those flat edges again, right? So I've got the bases, so I have 1 and 2, and then I have 3 sides that connect my bases. So I have 1, 2, 3, 4, 5. 5 faces. Now how many edges? Got to count up all my straight lines. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many vertices? It's all my points here. 1, 2, 3, 4, 5, 6. Now, for our pyramid over here, this is a square pyramid. And how many faces does it have? It has the base and 1, 2, 3, 4 faces. How many edges? I've got 1, 2, 3 in the back. You can't see it. And I've got 4. And then I've got the over here, 5, 6, 7, 8. How many vertices? 1, 2, 3, 4, 5. Okay, now let's go ahead and let's look into what exactly is surface area. We've been working with finding area for 2D shapes. Now we're going to go ahead and we're going to apply it to our 3D shapes. And it really is the same, except now I have to take into account all the edges of my shape. So here I've got a rectangular prism. My base is a rectangle. My edges here are all rectangles too. Now, when I find the surface area, think of like at Christmas time when you're wrapping a box or something. You need to cover all those flat surfaces. You don't want to accidentally forget to cover one edge or they'll know what you're giving them for a gift. So surface area, we've got to make sure we cover every edge of this. And so when we pull apart our prism here, let me lay it here. This is all of our faces of a cube here. So when I find the surface area, I need to make sure I cover every face and make sure I get the area of it. Then I'm going to go ahead and just add those numbers together. With our prisms here, I know I'm going to have 2 measurements of each thing. So this is our special equation that we have. I need to take the sum of the surface area of all of these different regions. So we can say this is my length, my width, and my height here. Okay, so when I go to find my surface area, I need to find my length times my width covers my base here. And I have 1 on the bottom that it's sitting on, and I have the 1 at the top. And so that's where I get 2 times length times width. So I'm taking care of the area at the base and the top of it. Now I have the 2 ends here. Okay, to get that area of this rectangle, I have to go width times the height. And because I have 2 of them, that's why my equation says 2 times width times height. And then I have to worry about this long edge here. I have 1 here in the front and 1 in the back you can't see. But that's why we have 2 length times height. Now, once I have measurements to it, I'm going to find the area, add them all together, and that gives me the total surface area. So let's actually do some examples here. Okay, so here's my first box. It kind of looks like a cube, but by the measurements we can tell it's not. Okay, so how are we going to do this? I know my surface area equals, I need to get the bottom and the top. Now I've got 2 of them. So I'm going to look at, how do I find the measure of the bottom? It is base times my, or length times my width here. So I'm going to go 4 times 5. So that takes care of the bottom and the top. Now let's take care of this side here. What is my measurement of this side? Well, it is 3 times my 4. Now that takes care of that side. What am I missing? I'm missing this front region right here. And that region here is 5. And then the height of this box, I have to look back here, and it's 3. So I have 2 of them because I have the 1 in front and I have the 1 directly in the back. And so I have 3 times 5. Now I'm going to go ahead and do my multiplication. 4 times 5 is 20, times 2 is 40. 3 times 4 is 12, times 2 is 24. 3 times 5 is 15, times 2 is 30. Add them all up. Oops. And I end up with 94. My measurements is decimeters. And we're doing area, so it has to be squared still. Okay, over here on this one, we're going to do the same thing. My surface area is the base. What is my base? It's 12 times 6. So I've got 2 of them. Plus, I have my ends here. I've got 6. I know I've got 2 of them, so I have 6. Now, what's my height? I might have to look over here on this side, and yep, it's 5. Now I got to do my front section right here, and that's going to be 5 times 12. And I forgot to stick the 2 in front there. Now we're going to just do the multiplication and add them all up. 6 times 12 is 72. So that would be 144. 6 times 5 is 30, times 2 is 60. 5 times 12 is 60, times 2 is 120. Add them all up, and I have 324. And what is my units? I'm using centimeters, and we're dealing with area, so it's squared. So surface area is not hard. We just got to remember that we need to get every face that we have here, its area, and add it together. Now, pyramids are a little bit different, okay? If you noticed here, let's flip it over. I'll show it all to you. Here's my pyramid. Remember, with a pyramid, we only have one base. So when I find the area of this pyramid, I have to find the area of the base. And so that is why we have S squared here, because we're dealing with a square. And remember, every face that connects to my base is a triangle. And so my area of my triangle is 1/2 base times height. And because this is a square, I have 4 triangles. So the official equation for this is the number of triangles times the area of the triangle plus the area of the base. Add them all up. So in this example here, it's a square. So the area of my square is 7 squared. And then the area of my triangles, I've got 4 of them. So that's where the 4 came from. And the area is base, which is 7, times the height. If you notice here, remember height is always perpendicular to my base. And so it gave me the measurement here of 8. Do the math. 7 times 8 is 56 divided by 2 is 28 times 4. Add them up and I get 161 centimeters squared. Let's do one more example and then you're good for the day here. So here's my example. Find the surface area. Remember, surface area is the number of triangles. Well, I've got a square again. So I know I have 4 triangles. The area of a triangle is 1/2 my base, which is 4. And my height, remember it's perpendicular. They give me my height is 6. And then I have to add to it the area of my square here. And so square, the area of a square is side squared. Now let's do our math here. So 4 times 6 is 24. 1/2 of 24 is 12. And 4 squared is 16. 4 times 12 is 48. Plus my 16. Now add them together. And I get 64. What are the units I'm using? Centimeters. And we're dealing with area, so it's squared. Okay, guys, I hope you understand how to find surface area. I look forward to talking to you tomorrow. Bye.